So, first things first, let's take a look at the calendar, what's left of it for December. We are currently on December 9th, Wednesday. Got about a week and a half left in the first semester. We have one last discussion board for today. I'll go over that at the end of class. Then I'll update our live class resources at the end of class. But this value of a car discussion board, that's the last discussion board. That's the last new assignment for the semester. All right. You guys could start your Unit 5 self-assessment if you like. That should be available. Let me make sure it is available. Yes, it's published. All right. So, real quick before we get started, let's take a look at this. Just like the other self-assessments, there's 3 parts. All right. The first part is a free response question about exponential functions. This self-assessment has 2 parts to the free response question. There's an exponential growth problem and an exponential decay problem. You know, those are the 2 main things that we covered in the exponential functions unit. The submission type for this is a file upload. All right, do your work by hand on paper, take a picture of your work and upload the picture as your submission. Okay, that's why it says choose a file. All right, that's going to be the easiest way to do it. If you want to do this on like a Word document or a Google document, you can definitely do that as well and upload that document as your file. The file upload will only take a single file. So if you're doing work by hand and you have more than 1 picture of your work and those are separate files, it's only going to let you upload 1. So if that's the case, take those 2 pictures and add those pictures into a document so that they're in a single file. Upload that file. Okay, if you need help with that, please let me know. And if all else fails and you're just not having success submitting that way, just email it to me so I have it. Right? Just put in the subject title of the email that it's the Unit 5 self-assessment. All right, but that's how this one is set up. It is a file upload for your responses to the free response questions. All right, both of these questions are essentially having you go through the same steps, just one's growth, one's decay. You're given a context, you're going to complete a table, write the noun extra, write the symbolic rule, and then answer a question about it. Okay. Part 2 is the reflection, same as it was on the previous couple self-assessments. And then your level of understanding based on how well you understand the content. You'll select your level. Okay. So the same as the previous 2 self-assessments, if you've seen those. If not, this might be brand new. That's okay. This is what it looks like. Is there any questions about the self-assessment? Okay. So then, if you're working through seeing things through the modules, a few things. I do have, again, I have videos for Unit 5 already loaded in here for exponential functions on our videos, right? We got 5 different videos, so you're welcome to look at those to see other worked examples of what we've been doing. And then we are in week 15. This is the same things that we saw on the calendar here. We've got our live class resources that'll be updated later today. The last discussion board, we'll have live class resources again on Friday. Doing our review. All right, and today we're doing an exponential decay review. I'm trying something different. I don't know how well it's going to work, but we're going to give it a shot. So hopefully that works out. And yeah, find out. So there's that. Any questions about this week? All right, and lastly, I do want to tell you guys one more time, next week will be different. That's why the schedule is in here, right? Monday is going to be the same as it has been. You're going to go to your period 1 class on Monday morning for a weekly lesson. All right, Tuesday is a traditional schedule. All right, so I will see you in the second class period of the day. All right, the block is scheduled from 9:32 to 10:27. We will not use the entirety of the block. All right, and then you will see me again on Wednesday for the second block of the day for the final. All right, and again, the day of the final, the expectation is that you complete work, essentially, to ensure that you pass the class. The bare minimum needed to be like checked out of class is to have submitted your self-assessments. All right, if those are submitted and you're happy with your grade and you're passing, you'll be allowed to like leave the class. You won't be marked absent or anything, and it'll just be like, hey, you're here, awesome, your stuff's in, cool, you're good to go. Otherwise, you should remain in the class, logged into Teams, and get work turned in so that if questions come up, I can help you. All right, that's the whole idea. The day of the final is to like make sure you can pass the class. All right, guys, so I'm putting a link in the chat for the activity we're going to do today to review exponential decay functions. All right, it is a Desmos activity. I'm not sure if you guys, how familiar you guys are with Desmos. I know I've shown it to you guys several times in the class, but we're going to be using it to do a activity. And let's see how that goes. All right, so here's our first screen. This is just a review type of screen here, all right, of what exponential decay is. All right, exponential decay functions help model situations where values are decreasing and their constant rate of decrease is defined with repeated multiplication by a value less than 1. For example, if a ball is dropped from a height of 35 feet and every time it bounces, the ball rebounds to 3/4 of its previous height, approximately how long will it take for the ball to come to rest? Type of question we could answer. Now, this context can be modeled with the exponential decay function y equals 35 times 0.75 to the power of x, where y represents the height after x number of bounces. Following table and graph also model this context. All right. So we have our graph here. Notice on the graph, if I put my mouse over it and I go to like a point that's already defined on the graph, it'll give me the coordinates. I can also just click my mouse and drag along the graph. All right, so a graph that's in one of these screens, if you see a graph in one of the next few screens, you can do this. It's not going to change the graph, right? But it'll allow you to see the values, right? Which could be helpful. I'm going to put the link to the activity in the chat one more time, just to be safe here. Okay. If anyone hadn't seen the link in the chat, there it is again. If you're just joining us, there's the link to the activity. All right. We also have this table here, right? Also showing number of bounces compared to the height in feet, right? At 0 bounces, meaning we haven't dropped, we're dropping the ball. It's at 35 feet. It bounces once, it goes up to a height of 26.25, bounces again, rebounds up to 19.67 feet, so on and so forth. Right, so these are ways that we can represent and model this situation in this context, right? So I'm going to advance to the next one. You guys can't advance yet. I will allow you to advance in just a moment. this first question is going to come up. You need to check box, right? These are all, you can put a check next to any of these. All right. Next to the functions that represent exponential decay, right? Only check the boxes next to the ones that represent exponential decay. Right? All right, so now you guys can move on to the next screen. Please select your responses. As you guys can see, I can see what you're doing. If you look at the shared screen here, I can see who's logged in, and I can see where you're at. So I can see that many of you have not moved on to the second screen. Move to the second screen. All right. So now, the correct answers. All right, y equals 55, and then in parentheses 1 minus 0.02 to the power of x. That is exponential decay. All right, we're subtracting something from 1. The value that is going to be multiplied over and over again is less than 1. All right, we get y equals 5,575 times 0.65 to the power of n is also exponential decay. And 14,000 times 0.92 to the power of x is also exponential decay. Once again, we are multiplying by a value less than 1. When you multiply by a value less than 1, but greater than 0, the numbers decrease each time. Right? The other three options were all exponential growth because we were multiplying by a number greater than 1. Is there any questions about this first problem? Our next screen here, for the following context, identify the correct symbolic rule and graph. All right. So there is one correct rule and one correct graph for this scenario. Right? The yearly profits of the company is $25,000. The profits have been decreasing by 6% per year. All right. Choose the correct y equals blah, blah, blah symbolic equation, and then the correct graph that goes along with this scenario. All right, so now, can someone volunteer and tell me what they think the proper function rule is or symbolic rule is out of the options we have available here? You can just say first one, second one, third one, fourth one, fifth one. All right. So Destiny is saying it is the third one because it is less than 1. All right.
I love your slides. I think everything looks really clear. I like the size of the font that you chose, and I like the pictures. If you've got some cool pictures, guys, be sure to explain them. These look like they're the dorm rooms at San Diego State. And then this is like a very famous photo for San Diego State. This is pretty much wherever.
Why am I hearing someone? Who was that? All right. Eileen also agrees with the third. Anthony agrees with the third. All right. So, okay, and Ari's saying she did the third one because it had 0.6 and not 0.6. Yes, third. Yes. Yes. So again, everyone who's commented so far, you are correct. It is the third option, 25,000 times 1 minus 0.06. 6% as a decimal is 0.06. We are losing 6%, so we're subtracting 6% from the whole. That gives us this 1 minus 0.06. And yes, Nicholas, it is multiplying by a number less than 1. That indicates exponential decay. Awesome. So now, which graph? Graph 1, graph 2, graph 3, graph 4? All right. So we had 1 vote for graph 1 and 1 vote for graph 2. Oh, okay. Thanks, Jocelyn. All right, Dusty's not sure on the graph. Okay. So let's see here then. If we're not entirely sure, let's look for evidence, right? We know what graph, or we know what rule, right? Right. And Eileen's not sure either. Okay, so now let's look at the different graphs. Let's first consider graph 1. In graph 1, right, our graph is to the left on the x values. So it would imply that we're going backwards in time. Is that possible? Not today. So graph 1 doesn't work just because it's going in the wrong direction, right? Our graph is going to the left, so it doesn't really work out. Graph 2, it starts in a reasonable spot, right? 25,000, right? It looks about to start in the right spot, and it's gradually decreasing, so that seems reasonable, right? Graph 3 starts in the right spot, but it goes backwards. That's not going to work out. Graph 4 also seems to start in the right spot, but it decreases pretty quick. All right. So we're kind of between graph 2 and graph 4. If you have to choose between 2 and 4, we know we're only losing 6%. So 6% is pretty gradual. I mean, I'm keeping 94%. We're going to end up going with graph 2 because it makes the most sense, essentially, right? It fits what's going on the best, right? And we could, okay, you're welcome, Destiny, yeah. We could test some numbers along the way, like, and try to kind of determine, like, hey, at 50 here, I can see this one, we're at a decently high value-ish, you know, it's hard to read the graph necessarily, but this one's showing a more gradual rate of decay. Graph 4 is going really fast. It drops off super quick, right? So we have rule 3, graph 2. Awesome. All right. Very good. So now, let's look at our next question. For the context below, write an exponential decay function and then answer the question that follows. Right? You bought $2,000 worth of stocks in 2012. The value of the stocks has been decreasing by 10% each year. Write an exponential decay function to represent the situation. Right? You're going to do that in the text box here. And then in the next entry here, what will your stock be worth in 2017? Round your answer to the nearest cent, so the nearest 2 decimal places. Right? And that answer you'll put in here. So we're at our 3 minutes. Let's think about this scenario. Where's everyone at here? Most of you guys have tried this so far. You're working on it. So now, let's think here. We have $2,000. Okay. It's a good question. I mean, I will show you guys. All right. I will show you how to get that done. We're going to look at this first part first. All right. We're running an exponential decay function to represent this situation. We have a $2,000 start value. Right. We're decreasing by 10%. Right. So we're writing this function, right? You can say y equals our start value, 2,000, times And there's a couple ways we can write this. We could use 1 minus 0.1, 0 for 1. And then we use this button here, the A with the little b, to put us up in that exponent spot, right, to the power of x. All right. And we can get to letters and stuff here if we want to use that. All right, so this is one way we can represent it. The other option is to actually just do the 1 minus 0.1 and have 0.90 or 0.9. Both representations are correct. Okay, and so now this is asking, what will your stock be worth in 2017? 2017 is 5 years after 2012. So we're replacing x with the value of 5 because it's representing years, right? We're doing each year, so our value of x represents years, right? So we will solve 2000. Here, let's do this. If you click this little guy, it makes it look more mathy, right? Well, 2000 times 0.9 to the power of 5, right? And we'll get an answer here. So now we want this. So what we can do here is if we want to open another tab and go to Desmos, just go to the graphing calculator. We can put that same thing in. Right? We can have 2000 times 0.9. We can throw the 0 on there. You don't need it. And then AB here, this A to the B, to the 5th power, and we get the answer. 1180.98. So we're using 0.9 because 1 minus 0.1 is 0.9. Right? So this right here, one minus 0.1, since that's within the parentheses, right? I can actually do that math if I want to and just represent 1 minus 0.1 as 0.9. We can also think of it as I lost 10%. That means I keep 90%. And we're always multiplying by, in an exponential function, we multiply by what we get to keep, what's left over, what remains. All right? If 10% is lost, 90% remains. All right? Does that help clarify? These are good questions. This is why we're doing this. Awesome. So again, look at our answer, 1180.98. Okay. Right. This would be the solution, right? There you have it. Right. Any other questions or anything else I can clarify about this example? All right. Next one here. All right. Use the provided context to create a graph. Well, I made the graph. I had to change this question because I couldn't make it work the way I wanted. And answer the question. All right. A piece of land was purchased for $65,000. The value of the land has slowly been decreasing by 1% annually every year. The graph below models the situation. All right. Use the graph to estimate how much the land will be worth in 20 years. All right. The years are along the x-axis. Right. We've got the amount of money this thing's worth is on the y-axis. We're going to round your answer to the nearest dollar. You just type your answer in here. Remember, on a graph like this, if you click on it with your mouse, you can drag the dot and it'll tell you the values. Right? The Desmos graphs are very usable in this way. So use that to try and find your solution. All right, so we're going to open this one up. Let's give it a shot. You guys can move on to the next frame. We're going to do, fast on this one. We're going to give you guys 1 minute to find this one out. Remember, drag that mouse along that graph. See if you can find the answer doing that, or at least something very close. That's been 1 minute. All right, so let's see. A few people who put their answers in. So let's look at this, guys. If you're still working on this, excellent. If you've submitted your answer, excellent. So if we use the fact that I can click on this line and drag a point, right? I want to drag a point so the first coordinate, which represents the number of years, is 20. Okay, that's our x value. So I'm going to try and get as close to 20 as I can. Right? Excellent. So it's going to be right there. Right? And so it doesn't let me leave the point there, but we can see it. At 20, we're at 53,163.95. Okay? So we can estimate, right? We're doing the nearest dollar, $53,164. We can $sign if we want. Right? And that's a good estimate, right? So we can use the graph. We can use this Desmos graph to get an answer than we could just by hand, trying to like trace to that point and estimating that way, right? We want to use the tools we have available. Is there any questions on this one and how to do that? Okay. All right, so next, you're given an entire Desmos graphing calculator. You're going to use the graphing calculator to graph the exponential decay function that models the height of a ball that is dropped from 18 feet and rebounds to 3/5 of its previous height each bounce. All right, so you're going to type in the y equals function rule into this little entry window here. Right? If you need to, you can open up the keypad so you can use the exponents and all that stuff. You get extra letters over here. Okay. So you're going to use this whole screen to enter in the graph. I've already set your x to be number of bounces, your y to be the height of the ball. And the window I've put in place here should work for this function so you can see what it is. So in here, the function you should have, right, should be y equals 18. Right, and then we'll put in parentheses. We can put the fraction right in here. We go 3 divided by 5. And it puts it in there as a fraction. You're going to need to click to the right so that your cursor moves out of the denominator spot. Close the parentheses. A to the B, x. Make that thing hide, and that's what the function should look like. Any questions on this one? All right. Move to the next one. So on this one, same scenario. Right? Ball being dropped from 18 feet, rebounds to 3/5 of its previous height each bounce. we're going to want to complete the table. All right. You might need a calculator handy. Choose the now next rule that goes along with the scenario and write the y equals rule, which we just saw. All right, so for our table, right now, I'm going to show you the easy way to find these answers. All right, if we go into our Desmos calculator, right, we put in our function rule, which we just used to create the graph on the previous question. Okay. And Hockman did point out that we could use a decimal representation of 0.6. That is the decimal of the fraction 3/5. We get this here. If I go to this little wheel, right, the little gear, and I say duplicate, then I'm going to say convert to table. Right? And I'm just going to edit these values in the X. 0, 1, 2, 3, 4, 5. Now I have all my answers. So we can calculate each one using a calculator if we like, or since we're already in the Desmos, right, and we already have access to this stuff, again, we're going to use the tools available, right, and I can get my values here, right, and then just enter them in. So the first one is 10.8 and 6.48. And it's teeny tiny, but 3.89, right? And so on. And we can enter in the table that way. Okay. So that hopefully is kind of helpful. Nice little helpful hint that you can use. Then the correct now next rule, right? The word now is always the one that's going to be multiplying by something. So the first rule doesn't work. We can't have next times. We don't know what next is. Okay. So the proper rule is the fourth option. Now times 3/5 equals next, starting at 18. Right. Our start value is 18. That goes here. Right. The multiplier is 3/5. That's being multiplied by now. Okay. So this is our proper now next rule. All right. And again, we have our symbolic rule. Right. We have y equals 18 times 0.6 to the x. Any other questions? Anything else I can clarify on this one, guys? Ladies and gentlemen. The now next. Okay. So with a now next rule, all right, it's always going to follow the same format. All right, we're going to have now. In this case, with exponential functions, it's going to be times a number equals next, comma, starting at, and then we put in whatever the start number was, right? For this scenario, right, the multiplier is the 3/5, which can also be done as the decimal 0.6, okay? I use the fraction here in your options, right? So it's now times, right, the thing that's being multiplied, 3/5 equals next. So if I multiply 18 times 3/5, I'll get the next value. Right? That's why we say now next. I use the value I know now, do this thing to it, and it gets me the next value. Right? And in a now next rule, we have to provide the starting point to the reader, so to say. They need to know which number is the first now number. In this case, the first number we use is 18. So that's the starting at number. Okay? So just like in a function rule, we need the start value and the rate of change. We use those same two numbers in the now next rule, right? Now times the rate of change, in this case 3/5, starting at our start value or y-intercept, 18. Okay. Does that clarify? Or would you like to see a different example? You're welcome. You're welcome, Destiny. Nicholas, was that good? Did that clarify what you needed as well? You're welcome. You're welcome. Excellent. Okay. So we're at 9:34. Okay. I have one more thing, one more task within this activity, but I think we're not going to do it today. We'll do it next class when we're doing our entire review of exponential functions because it's already 9:30. So last thing we're going to do, let's do this. Pause that. Gonna go here. That's not what I wanted. All right. So to review our last discussion board, there's 2 questions on it. You just bought a new car, costs $42,500. The value of your car decreases by 15% annually. You're going to write the symbolic rule, y equals. That represents the exponential decay of the value of the car. So remember, if it's losing 15%, right, the thing I multiply by is the amount that is kept. So if it lost 15%, it keeps 85%, right? And you need to determine what will be the value of the car in 7 years.